Hello class, today we are taking a look at equations that have brackets in them, and to be able to work with these equations we know that we are going to use what's called the distributive property. So when we take a look at our first equation here and we've got our 2 brackets x plus 3 and brackets equals 4, when we solve that out pictorially we want to recognize that our 2 here is 2 groups. Anytime we have multiplication we can think of our number of groups. So we're going to want to set up 2 groups, and in each of those groups, we need 1 positive x and 3 positive constants. So let's go ahead and draw that. We've got 1 positive x and 3 constants. And then we need 2 groups of that, so let's draw that again. 1 positive x and 3 constants. And then we can draw our wall as well, our equal sign. On the other side, of course, we've just got our 4 positive constants. So with those, I'm going to go ahead and sort them into 2 rows with my 2 x's. So I'm going to go ahead and go 1, 2, 3, 4 positive constants there. Okay. Now, in terms of our algebraic work, we can actually see from our pictorial work what we get when we expand those brackets using our distributive property. Expand means we need to multiply the number outside the brackets by each number inside the brackets, or each value inside the brackets. So 2 multiplied by x is just 2x. And 2x, of course, has that implied multiplication. And then 2 multiplied by positive 3 is plus 6. Okay, 2 times positive 3 is positive 6. Of course, there were no brackets on the other side of the equal sign, so we just have our 4. If we look in our diagram, we do in fact have 2 x's, and that's what we said we have. And we also have a total of 1, 2, 3, 4, 5, 6 constants, and that's also what we said we have. So far our work between our algebraic and our symbolic work, our pictorial work and our symbolic work does in fact match. From here I don't have any negative x's, so I don't need step 2. I can move on then to canceling out my constants. In my equation, I have some positive constants on the same side as the x's. Those are going to need to cancel with a negative constant each. And I'm going to need to add 6 total negatives to that side to cancel out all those positives. What I do to the right side, I have to do the left side and vice versa. So I'm going to have to add 6 total negatives on this right side as well. Okay, that's 4 right there, and then 5, 6 that don't have a 0 pair. Last thing to do is to identify what 1x is worth. So having sorted these into rows already, I can see that each of my x's has a worth of 1 negative. I can say x equals -1 is my solution. Remember, everything else is crossed out, doesn't exist anymore. In terms of my algebraic work, I again don't have negative x's, so I don't need to worry about those. Next thing I'm going to do is I'm going to undo addition or subtraction to x. Here is x. It is being added to by 6 currently. The opposite of adding 6 is subtracting 6, and what I do to the left side, I have to do the right side as well. Okay, my positive 6 and my minus 6 cancel out. I do still have my 2x on the left side. On the right side, 4 take away 6 is -2. Finishing up, I need to undo the multiplication or division of x. X is currently being multiplied by 2. The opposite of that is dividing by 2. And of course, what I do to the left, I have to do to the right. 2 cancels with 2, leaving me with x, and -2 divided by 2 is -1. And of course, I did get the same solution from my symbolic work and my pictorial work. To finish up, I need to verify that solution. Oops. In verifying a solution, I want to check that the original left side of the equation, which was 2 brackets x plus 3, evaluates to the same number as the original right side of the equation, which in this case it was just 4. And that's when I substitute in my value for x. Okay, I think that x is the number -1, so let's substitute that in. 2 brackets -1 plus 3. Okay, I need to do the operation inside those brackets first when I'm calculating. -1 plus 3 is +2, and 2 times +2 is +4. Since we get +4 on both sides of the equal sign, our left side does equal our right side, and our equation is verified. Let's do another one here. We've got 6 equals 3 brackets x minus 1. So let's go ahead and start setting this up. I'm just going to move this over a bit here to give us some space to draw our diagram. Okay, from here I'm going to draw my wall, and then let's go ahead and sketch in what we have. On the left side is going to be pretty straightforward. We just have 6 constants. To figure out where we want to put those 6 constants, let's go ahead and think about our right side. We know our 3 out front is going to be 3 groups, and in each of those groups I'm going to need 1 positive x and 1 negative constant. So I'm going to go for, there's a positive x and a negative constant, and I need 3 groups of that. So here's a second group of that, positive x, negative constant, and a third group, positive x, and a negative constant. Okay, so that's 3 groups of 1 positive x and 1 negative constant. On the other side, I'm going to sort my 6 positives into 3 rows. So 1, 2, 3, 4, 5, 6. Okay, again, in terms of my symbolic work, I've got my 3 brackets x minus 1. I know that my 3 needs to multiply by each thing inside the brackets, so 3 times x is 3x, and 3 times -1 is -3. Okay, next thing to do is to check for any negative x's. We do not have any here, so we can skip to step 2. Step 3 is to cancel out our constants that are on the same side of the equation as our x. We do have these 3 negative constants over here that are with our x's. To cancel those, we're going to need 3 positive constants on the right side. And of course, what I do the right side, I have to do the left side as well. So 3 positive constants over there as well. In terms of our algebraic work, we need to undo subtracting 3 by adding 3. And what I do to the left side, I do the right side, and vice versa. Okay, obviously our 3 cancels with -3. We do still have 3x. On the other side, 6 plus 3 is 9. Finishing up, I want to figure out what the value of each x is worth. So 1x I can see is worth 3 positives, and so I can conclude that x is equal to 3. In terms of my symbolic work, the opposite of multiplying x by 3 is dividing by 3. We'll cancel out our 3's over here, leaving us with x, and 9 divided by 3 on the other side is 3. Again, obviously same solution from both the pictorial and the symbolic work. Okay, let's verify. We want to check the left side and the right side of our original equation. Original left side was just 6. The original right side was 3, brackets, whatever x is, and then take away 1. In this case, we think that x is the number positive 3. And from that, we need to subtract 1 inside our brackets. 3 take away 1 is 2, and 3 times 2 is 6. In fact, the left side does equal the right side, so our solution is verified. Okay, in question C, again, we're going to start by thinking about our groups. We are going to go ahead and have, again, let's give ourselves some space here. Move that over a bit. Okay, draw our wall. We need 2 groups of a positive x and 5 constants. So let's draw those. Here's one group of a positive x and 1, 2, 3, 4, 5 positive constants. And then here's a second group of a positive x and 1, 2, 3, 4, 5 positive constants. Okay, On the other side, of course, I've just got my two negative constants. I'll put those into those two rows. Okay, in terms of our algebraic work, 2 brackets x 5 plus x end brackets equals -2. We again want to expand our brackets by distributing that 2 into our brackets. 2 times 5 is 10, and 2 times positive x is plus 2x. On the other side, we just have our -2. Okay, from here, I don't have any negative x's, so I don't need to worry about canceling those. Next thing to do is step 3, to cancel our constants and do addition and subtraction. I do have 10 total constants over here that I'm going to need to cancel out with 10 negatives. And if I add 10 to the left side, I must add 10 to the right side. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 negatives added to both sides. Okay, in terms of my symbolic work, I'm going to go ahead and subtract 10 from both sides. That's the opposite of adding 10. I do still have a 2x on the left, and -2 getting further negative by 10 is -12 in total. Okay, last thing to do is to split up to see what one x is worth, so I can see that each of my x's has a value of 6 negatives, so I can say x equals -6. Okay, on the other side of our equation, we are going to go ahead and divide by 2, since that's the opposite of multiplying x by 2. We're left with x on the left side, and -12 divided by 2 is -6 on the right side. So that is our solution. We don't need quite that big a wall there. Okay, let's go ahead and verify. We want to take a look at our original left side and right side of our equation. Original left side was 2 brackets 5 plus whatever x is, end brackets, and the original right side was -2. Okay, we want to substitute in that we think x is the number -6. We want to calculate inside the brackets there. 5 plus -6 is -1, and 2 times -1 is -2. Since -2 does equal -2, the left side does equal the right side, and our solution is verified. Okay, question D, same type of deal again. Might again give myself a bit of space. Okay, let's draw our wall. Okay, we are going to go ahead and make 4 groups with 1 positive constant and 1 negative x. So here's a negative x and a positive constant, and I need 4 groups of that. So here's a second, third, fourth, and then of course second, third, fourth. So 4 groups of 1 negative x and a positive constant. Okay, other side I have 8 positives, so I'll just go ahead and sketch those in. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay. From here, I do have negative x's, so those are going to need to cancel out with a positive x each. So I'm going to go ahead and add a positive x here. Guess I could have left myself a bit more space, but that's okay. 2, 3, 4. To cancel my 4 negative x's. And that means I have to add 4 positive x's to the other side as well. 1, 2, 3, 4. Okay. And just looking at what I have here, I do want my constants to be sorted into rows with the x's that I do have. And of course, those are these x's over here. And so I'm just going to go ahead and erase down my blue x's here and just move them down into this 4th row over here. There we go. Okay. All right, next thing to do is to cancel out the constants that are on the same side as the x's. The only x's I have currently are on the right side. There's 8 constants there. that are going to need to cancel with 8 negatives. Okay, if I add 8 negatives to the right, I'm going to have to add 8 negatives to the left as well. Okay, and we do have some 0 pairs there. That can cancel out. Last thing to do is to match up what 1x is worth, and we can see that 1x has a value of -1. Okay. In terms of our algebraic work, for brackets 1 take away x equals 8, we again want to start by expanding those brackets. 4 times 1 is 4. 4 times -x is -4x. And on the other side, just our 8. Next thing to do is cancel out our negative x's. We're going to do that by adding 4x to both sides. Okay, minus 4x and plus 4x cancel on the left side. We still have our constant 4. On the other side, 8 is a constant, 4x is a variable. Those can't combine together. Next thing to do is undo the addition or subtraction to x. The only thing being added to our x right now is 8. The opposite of adding 8 is subtracting 8. We'll do that from both sides. 4 take away 8 is -4. And on the other side, we still have our 4x. Last thing to do is undo multiplication or division. Right now, x is being multiplied by 4. The opposite of that is dividing by 4. We're left with x on the right side, and -4 divided by 4 is -1 on the left side. Okay, verifying that. We want to look at the original left side and the original right side of our equation. Check that they are equal. The original left side was 4 brackets 1 take away x. So we want to do 1 take away whatever we think x is. And the original right side was 8. Okay, we think that x is -1. So we'll do 4 brackets 1 take away -1. And 1 take away -1 is the same as 1 plus +1 by the add the opposite rule. So that's 4 times 2. And 4 times 2, of course, is in fact 8. And 8 does equal 8. So the left side does equal the right side, and we are verified. Solving algebraically, same type of deal. Start with your wall. We want to expand our brackets first. -2 times x is -2x. -2 times +3 is -6. Other side, we have our 4. Okay, we do have negative x's here, so we're going to want to cancel those out. We're going to add 2x to both sides. -2x cancels with positive 2x. We still have our -6 there, and on the other side, 4 plus 2x. From here, we're going to undo addition. The opposite of adding 4 is subtracting 4. -6 getting further negative by 4 is -10. And on the other side, our 4's cancel out, leaving us with 2x. And we're going to undo that multiplication of 2 by dividing by 2. Yeah, x equals -5. We do want to verify our solution here, even though we were asked to solve just algebraically. I mean, we were asked to verify it as well. Let's look at our left side and our right side and check that they are equal. Left side was -2 times whatever x is, plus 3. And the original right side was 4. We have -2 times, we think x is -5, and we want to add 3. Okay, -5 plus 3 is -2, and -2 times -2 is +4, and +4 does equal 4, so the left side does equal the right side. Last one here, again, we're going to start by expanding. So we're going to multiply our -3 by 6 to get -18. And -3 times +2x is -6x. On the other side, just have our 10. Okay, we do have negative x's here. So step 2 is to cancel out our negative x's. We're going to add 6x to both sides. We still have -18 on the left, and on the right, we have 10 plus our 6x. Next thing to do is undo addition or subtraction. The opposite of adding 10 is subtracting 10 from both sides. Okay, 10 cancels with -10. We still have our 6x on the right side. On the left side, -18 getting further negative by 10. is negative 28. Okay, last thing to do is to go ahead and divide. So we are going to want to go ahead and divide both sides by our our 6, sorry. And dividing both sides by 6. 28 won't divide evenly by 6, obviously. So 6 goes into 28 a full 4 times. That would be 24. And an extra 4 out of 6 would be left over. So this would be a case where we do have a mixed number as a fraction. I guess I should change that one. Oh well. I think I'll change this for grade 8. I'm going to change this down to, oh, what do we need? Let's do 12. So process remains the same. We just want to change all these. That's a bit better. Now we'll get negative 30 here. And 30 will divide nicely by 6. We just shouldn't have a negative fraction answer like that in grade 8 as well. Okay, negative 30 divided by 6 is negative 5. Okay, so hopefully that helped you with your expanding, especially with your drawings, and how to solve an equation that does have brackets. So I hope that helps.